Hey, welcome to math. Today we are in chapter 8, looking at section 2, classifying angles. So we're going to start by looking at what is an angle? Why are angles important to us? Well, let's see. If you are a pilot, you would really like to take off and land your plane at appropriate angles with the ground so that, well, you don't crash. If you're a basketball player, you want to be able to hit the backboard at just the right angle so that when it bounces into the net. There are a lot of different ways to look at angles, so we've got to understand the basics, and that's what this section's about. So we're going to start by defining angles. An angle is formed by two rays. Remember, a ray is a line that it starts at a point and it goes in one direction. And these are joined at a vertex, which is a point. So for example, this is going to be angle ABC. This ray starts at angle B and goes in this direction. This one starts here and goes in this direction. We write this angle ABC. We always put the vertex in the middle. We could call this angle CBA and it would be just fine because the B is in the middle. We cannot call this angle ACB. That's illegal. They'll come and get you. All right. We have four ways that we classify angles. And I'm pretty sure you've seen these before, but it's always good to review. Our right angle is exactly 90 degrees. Now, as you get older, you'll notice that we put this nice little square in here, and this square means exactly 90 degrees. If you see an angle that looks like it's 90 degrees, but it doesn't have that square in, it could very well be 89.4 degrees, and you don't want to trust it. You have to make sure it's 90. This little square says, yes, I guarantee it, so always look for that. If it doesn't have it, beware. Acute angles are smaller than 90 degrees. They're cute little guys. Obtuse angles are larger. And then we have a straight angle. I think this is new to you this year. A straight angle is exactly 180 degrees. So this is actually an angle opened all the way up so that it makes a completely straight line. Straight angle, straight line. I'm hoping you're going to remember that. So now, we're going to mess with the angles. Now that we have our angles and we understand their meanings and how to discuss them, now we can talk about actually putting some numbers to them. So one of the first things we look at are the idea of complementary angles and supplementary angles. Our complementary angles are two angles that add up to 90 degrees. Notice, please, it's complementary. If this was an I, you would be giving it a complement, so make sure you spell them right. And then you have supplementary angles, and these are two angles that add to 180 degrees. For example, here, look, two angles. I have angle ABC here, and I have angle DEF here. And if I were to put these two together, and you can kind of imagine just kind of sliding this over, if you were to put these two together, it would make a 90-degree angle. These two angles are complementary to each other. If you add them up, if you actually measured them out, their totals would equal 90 degrees. Same goes for here with supplementary. Here, this angle ABC over here, when paired with this angle DEF, if you moved this over, this would equal 180 degrees. So these two angles are supplementary. And now we finally get to do some math. So I've drawn for you here a happy little protractor. A protractor looks like this, and unlike my 5th grade, who called this a smile ruler, it's not. This is a ruler that actually measures the degrees of your angle measurements. So I've drawn you one so we can mess with it. I've got a number of angles indicated here. I've got rays coming out from the vertex point G, rays A through F, and they make a number of angles. Now I could make angle AGB with it. Hello? Yes?